Welcome to Hot Topics. I got a interesting phone call the other day, and it was from a safety engineer whom I think a great deal of. He's a very well trained engineer that's over safety at a very large facility. And he wanted to know basically why did the company require low voltage to be evaluated before you work on it. And he just didn't understand the table of in the code. It said if you was less than 50 volts, you really didn't have to wear your PPE and that kind of thing. It just wasn't addressed in the table at all. And we're talking about, your low voltage table and high voltage and medium voltage type table, as well as your lower voltage table, 130.4 EA. Now, I basically said, well, the first thing you have to do to really understand that, and you and I, it doesn't matter if we're engineers or electricians, we still have to know about this low voltage. Now, first of all, we want to go to NFPA 70E, the 2021 edition, and we want to look at 110.4C as in car, and it's equipment operating at less than 50 volts. And it reads, just so that you might not have your 70 handy, we'll read it to you. The title head is equipment operating at less than 50 volts. Energized circuit conductors and circuit parts that operate at less than 50 volts shall not be required to be de-energized. And then, of course, here it comes, where the capacity of the source and the overcurrent protection device regulates the energy source and the worker are considered to be safe if determined that there will be no increased component exposure that would create a shock that could be harmful, or electrical arc that could create a burn, say beyond a second degree burn. Now I'm kind of paraphrasing as I go through this, but you can read it in its entirety in 110.4C as in car and NFPA 70E. Now, he was concerned. He said, I thought, you could work on class 1, 2, or 3 circuits without any problem at all. But now, again, 70E gives some information that's important to us. So we want to look at Article 100 of 70E, and we want to read the definition. Remember this, electrical hazard. And it basically says that only a class 2 power source listed with low voltage for lighting systems and similar type equipment such as computers and things like that are examples of circuits that 70E and OSHA do not consider a problem. Now we find this same permission in OSHA 1910 308.C as in car. You can read that in OSHA 1910 308.C. Well, that's not correct. 1910 308C. I'm sorry. And you can read where they have the same type permissive rule when they're addressing their class 1, 2, and 3 circuits. If you want to read 70B, the maintenance standard for electricians, just go to chapter 7, and it refers you to the NEC for a class 2 and 3 circuit. So you will find that now in chapter 7 in NFPA 70B. Now, when we look at the illustration that's on your screen here, then you notice that control circuitry We're talking about on the secondary side of a control transformer maybe, or any type of class 2 circuit. Notice 725.41a deals with class 1 circuits, as you see in the illustration, to the right, top hand side of the illustration. And they're power limited. And they usually operate, are permissible to operate at 30 volts or less, and 1,000 volt amps or less. But usually you will find those operating at 30 volts or less, at 100 volt amps or less, is usually what you would find for that class 1 circuit. And then the second circuit that you're looking at is 725.41b, and that's a non-power limited circuit. They can operate at 120, 208, 240, 480, mainly is what we're used to seeing. And notice in the illustration, left-hand side of the illustration down at the bottom, you see the non-power limited circuits, 120, 208, 240, 480, 450, 600 volts, see? And then to the right, you see the power limited circuits. That you have to go to your table 11A and 11B, as well as C, there in chapter 9 of the NEC, and you see that's note 3 that we're looking at the right hand side of the illustration down at the bottom. And then note 2 is just re-identification, where you can re-identify these circuits under certain conditions. But notice you have to look at 725.130a, exception 2. Many times folks wants to know, if we have a control circuit routed with the phase conductors, and you had 5 of them, a lot of engineers, electricians, inspectors says, now you got a D rate. Well, no, you would go over and look at table 310.16 in the NEC, and if you had a number 1420 amp conductors, you see in the left-hand side of the illustration at the very top, take 10% of it from 725.51b as in boy 2, and you have 2 amps. Now notice in the illustration, you have 3 power conductors and 2 control circuits. But the number 14 control circuits is only 1 amp, so you haven't exceeded step 2 to the left-hand side of the illustration, where the 2 amps is derived from 10% of 20. So you would not necessarily, you wouldn't consider them current carrying conductors. Now, so you're either looking at 725.41a and b for class 1 circuits, and those can be harmful to you under certain conditions, so you really want to check them. But when you get into a class 2 circuit in 725.121 of the code, you would go over to step 3, as you see here, in step 3, maybe it's a better word, and you'd pick up your tables 11A and 11B, and that would give you those outputs that you see in the illustration to the left at the very bottom. Now, we're not really worried that much about a class 2. Like the chimes in your home, that's usually a class 2 circuit. It's not harmful to you. You might get a little tingle, but it's a high impedance winding. It's just not going to give off enough energy to shock you real bad or create an arc that could burn you beyond a 2nd degree burn, which OSHA does. They say, no, you can't be burnt past a 2nd degree burn, even with your PPE on. So we pick all that information up in NFPA 70E and then OSHA 1910.331 through 333. You can pick all that information up to satisfy what we're talking about here. But now notice the class 2 circuit is outlined in the blue typing, and you go to 70E Article 100, electrical hazard, and that defines it as a class 2 circuit, not harmful to you because of the energy output is limited, see. But a class 1 and 3, that's not always true, as you see in that illustration. If you look at the illustration at the left, at the very bottom of the left-hand side of the page of the illustration, you notice that it can operate at 60 volts all the way up to 150 volts, a class 3. They can be a shock hazard. In some cases, might even be a electrical arc hazard to you, see. So this illustration is outlining your 725.41A and B circuits that are class 1 power limited and non-power limited type circuits that you would have. And then it also illustrates your class 2 circuit that you'd have there. And you notice you have your note 1. It gives you the information for your 725.41A and B circuits. And in class 2 tells you how in some cases they can even be re-identified and reclassified for you. And then note 3 comes down and tells you, no, class 2 and 3 circuits, your outputs are found in tables 11A and 11B in your chapter 9 at the very back of your code book. So this is dealing with your class 1, class 2, and class 3 circuits that we want to look at. Now, in our next illustration that you see coming up, is figure 4-17 in Stallcup's electrical design book, volume 1. And the previous illustration that we looked at is, I believe, 4-16, I believe. But now notice here, class 2 and class 3 circuits. Notice that most of your class 2, say 2 circuits, had a little trouble getting that out. You feed them with 120 volt, maybe a little transformer, and it's 30 volts or less. It's your energy output or whatever it may be. But they're usually about 100 volt amps or less. But notice when you deal with this power unlimited circuit, which we deal with in 725.41A, notice they're designed that they could operate at 1,000 volt amps or less, at 30 volts or less, depending on the amount of output that you needed. And these circuits can usually use where you need more power to keep certain types of equipment energized, like a coil on a controller and so forth. But notice the note tells you that the voltage ratings and overcurrent protection device are based on either they're inherently or non-inherently protected. And that would be naturally your class 2 and class 3 circuits. But your class 1, you always have to review their outputs and their voltage ratings, so forth, in 725.41. But remember, class 2 and 3, you go to 725.121, and to get a good feel on their outputs, go to your table A, B, and C of chapter 9 in the back of the NEC codebook. Now, folks, there you have why it's very important that 110.4C as in car and 70E requires low voltage systems to be evaluated before you work on them. But a class 2, they don't tell you that. But for class 1 and 3, yes, you would need to evaluate those circuits because they might be a shock hazard. Most designers say, well, your skin. That's why they start with that 50 volt rule. Your skin usually is a pretty good insulator up to about, less than 50 volts. But if current should penetrate through the skin, then you can read up on this, and with more information, like at the annexes in the back of 70E and 70B, you can read about it. That if any kind of, say, a milliamp rating, a certain value, current, penetrates through the skin and gets into your arm, say, it begins, if you don't, de-energize it real quick or cause it to open up a circuit in some manner, the longer it's flowing through your inside your body there through the skin, it can heat up the liquids. It can also deteriorate bone structure. So that's why they want you to evaluate it, because sometimes if you don't get away from it, it can do some damage to the hand and to the fingers, so forth, as well as other parts of your body, depending on the condition and how long the current flows through the body, even in a milliamp rating after you get up to a certain milliamp. Now you can go online, the BLS, you can look at the Bureau of Labor Statistics, and they'll give you all this information on these milliamp ratings, what's dangerous and what is not, as well as you could go to Article 340 and 70E and pick up a lot of good information, as well as back in the annexes of 70B, I believe now you can pick up some of that information also. But there you have it. That's what we wanted to cover in this video. Was it necessary, or is it necessary, that we should evaluate Class 1 and 2, 3, Class 1, Class 2, or Class 3 circuits? And mainly it's only the Class 2 that they say was not really a great hazard to you. So as we said many times, there you have it. My name is James Gray Stallcup. Thank you for reviewing and watching this video.